In this video, we will going to take up one more problem on composite materials. The problem reads as, so here, the problem number 52, a steel rod of 20 mm diameter is enclosed centrally in a hollow copper tube of external diameter 40 mm and internal diameter 25 mm. So he says a steel rod of 20 mm diameter. So this is a steel rod of 20 mm diameter is enclosed centrally. It is in the center of the hollow tube of copper tube having external diameter. So this outer line and this outer line gives the dimension of diameter 40 and the internal diameter of 25 mm. So between these two, this diameter will going to be 25. The composite bar is then subjected to an axial pull of 50 kilonewton through a rigid cover plate. So this is the cover plate which has been pulled by a 50 kilonewton load. If the length of each bar is equal to the length of the steel bar and the length of the copper tube is equal to 200 mm. Determine number 1, stress in the rod and tube. So what are the stresses developed in the steel rod and also on the copper tube? And then the load carried by each bar. So what are the loads? That is PS and PCU, or PC is the one which we need to calculate, and also the total elongation of the assembly, because as we have been applied with the tensile load, naturally the bars and the tube will going to be gets elongated. So the Young's modulus of steel is 2 into 10 to the power of 5 Newton per mm square, and Young's modulus of copper equals 1 into 10 to the power of 5 Newton per mm square. Now to solve this, so first what we need to do, first we need to find out what are the stresses in the rod and the tube. So to find out that, so what that is, we need to find out the sigma S and sigma Cu, that is the copper tube. So if you want to find out that, first we need to find out what is the area of cross section. Why? Because stress is nothing but the load by area of cross section. So area of cross section of steel AS will be equal to, as the diameter is given to be 20, so pi by 4 into 20 square is the area of cross section as it is a circle. So once you calculate that, you will going to get the value as 314.16 mm square. Now we need to find out area of the copper tube. Since we need to find out the area of copper tube, which is ACU, which are AC, which will be equal to pi by 4 into outer diameter minus inner diameter square. So that is d naught square minus di square into pi by 4. So that is the meaning of that, wherein pi into, we have the 40 square because the outer diameter is 40 and the inner diameter is 25 square. So pi into 40 square minus 25 square into by divided by 4. So on simplification, you are going to get this value, which is 765.763 mm square. So now we found out the area of steel and the area of copper. Then what we need to find out is we need to take the load. So what is the load? The total load what is coming on the bar is 50 kilonewton. So the load is shared by both the steel rod and the copper tube. So therefore, the load carried by steel rod plus load carried by the copper tube will be equal to total applied pull. So what is the load? The load carried by steel rod is PS plus the load carried by the copper tube is PC is equal to the total applied pull, which is equal to capital P. So that is what we got here. So once you get this, then we need to know, so we don't know the value of PS and also we don't know the value of PCU or PC, but we know the total load, which is 50 kilonewton. So here, then we have what is PS. PS is nothing but the load, which is stress is the load by area of cross section. Since we need to find out the value of PS, so therefore sigma S into AS is equal to PS. So in that case, sigma S into AS plus sigma CU into ACU will be equal to the total load, which is 50 into 10 to the power of 3. That is because he has given 50 kilonewton. we have converted that kilonewton into Newton, which will be 50 into 10 to the power of 3. Now we need to also we know that since we know the elongation, the total elongation will be equal to the elongation in the steel rod will be equal to elongation in the copper tube. So to do that, the deformation, we have the deformation formula, which is delta L, which will be equal to P into L by A into E. So in this case, PS into LS by AS into ES will be equal to PCU into LCU by ACU into ECU. So that is what we have got here. So what we know is PS by AS, it is nothing but sigma S. So sigma S into LS by ES is equal to sigma CU into LCU by ECU. So that is what we got now. But we know the length of we know LS is equal to LCU. So naturally that will going to be gets cancelled. So sigma S by ES is equal to sigma CU by ECU. Now substituting the value of the Young's modulus of steel and the Young's modulus of copper tube. Therefore, sigma S by 2 into 10 to the power of 5 is equal to sigma CU into 1 sigma CU by 1 into 10 to the power of 5. The value of LS is equal to LCU. Therefore, those two gets will go into cancels. Therefore, sigma S will be 2 times the sigma CU. On simplification, you will going to get this. Now, the next thing what we need to know is, we know you substitute those values here. What is there? We have to substitute here. We know sigma S is equal to 2 into sigma CU into area of steel is 314.16 is equal plus sigma CU as it is we write into ACU. Substitute the value of ACU, which is 765.763, which will be equal to 50 into 10 to the power of 3. So once you do that, so you will going to get this value 50 into 10 to the power of 3. Now on simplification, you will going to get the stress in the copper tube. The stress in the copper tube will be equal to 35.866 Newton per mm square. Now once you get the value of sigma CU, so you will going to get the stress induced in the steel tube, also 2 into sigma CU. Stress induced in the steel rod is equal to 2 into sigma CU value is 35.866. On calculation, you will going to get the value as 71.732 Newton per mm square. So once you know the stresses in both steel rod and the copper tube, it is very easy to find out the value of the load carried by individual copper and also the steel. That is because we know that PS is equal to sigma S into AS. So we know the value of area of cross section and you know the value of stress. So we can easily find out that. So the load carried by each bar will be equal to load on steel rod will be equal to PS is equal to sigma S into AS. You know the value of sigma S as 71.732 and also the area of steel is 314.16, which has been calculated in the earlier case. So that will be equal to 225.35 which is that is Newton. So in terms of kilonewton, if you say 22.54 will going to be, or 535 will going to be the kilonewton. Similarly, load on the copper tube will be equal to PCU is equal to sigma CU into ACU. We know the value of sigma CU, which is 35.866 into 765.763, which will be equal to the 274.64.8, that is 27,464.8 Newton. So in terms of kilonewton, 27.465 will going to be kilonewton. Then we need to know what is the elongation of the assembly. Elongation of the assembly is nothing but the total elongation of the assembly, that is the elongation of the steel rod and the copper tube. Since both have been covered with a rigid plate having the length are equal, so naturally the deformation in the copper will going to be the same as the deformation in the steel rod. So that means delta L will be equal to, either it can be delta LS or delta CU. Either you can use the formula here, which is delta LS is delta L will be equal to PS into LS by AS into ES, or delta L will be equal to PCU into LCU by ACU into ECU. So Here, either you can use that or this. So here we have calculated by using PS into LS by AS into ES. So here, substitute the values of PS, LS, AS into ES. Or since you know the value of sigma S, also you can take that as sigma S into LS by ES. You know the value of stress, which is 71.32, 71.732 into the length of the steel rod, which is 200 divided by 2 into 10 to the power of 5, which will be equal to 0.0717. So this is how you will be able to solve this problem. Thank you.